Assalamu-Alaikum dear students. I am Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will talk about Arndt Eistert homologation reaction. In Arndt Eistert homologation reaction, the homologous carboxylic acid or their derivatives will be prepared from carboxylic acid by reacting it with diazomethane in the presence of silver oxide. Let's have a look to the acid. Let's suppose this is the structure of ethanoic acid or acetic acid. When acetic acid reacted with thionyl chloride and then with diazomethane in the presence of silver oxide, what type of product will be produced? It will be converted into propanoic acid. If we compare the starting material and the product, this is the starting material and this is the product. The product is only differed by CH2 group. So this is the alkyl group. Let's suppose this is R. If we replace R, we have any type of carboxylic acid. So this is R, R, CH, R, CH2 carboxylic group. Here CH2 is inserted in between R group and carboxylic group. There CH2 group is inserted between R and carboxylic group. This is the homologated carboxylic group. What will be the mechanism for this reaction? Let's have a look to the reaction mechanism. In the first step, carboxylic acid will react with thionyl chloride and it is converted into acid halide. R C double bond OH react with thionyl chloride. This is the structure for thionyl chloride. OH of carboxylic acid will attack on sulfur of thionyl chloride. Bond will break toward oxygen atom and negative charge will be applied on oxygen, and again this bond will be reformed like this, and one of the bond between sulfur and chlorine will break toward chlorine atom, and this chlorine atom will remove in the form of chloride ion. So the final structure for this step will be like this. What will be the charge on this oxygen atom? Positive charge. Here chlorine atom or chloride ion. Now this chloride ion will attack on carbonylic carbon of carboxylic acid. First bond will be break toward oxygen, again it will be reformed and the bond will break towards oxygen atom. So it will produce acid halide. What other side product will be produced? SO2 plus HCl. As a result of this HCl, the reaction mixture will be acidic in nature. In the next step, when acid halide is formed, diazomethane, this is the structure of diazomethane. Diazomethane will be attacked on this carbonylic carbon of acid halide. So the bond will be break toward oxygen atom and negative charge will be applied on oxygen. This is the structure for this reaction. And in the next step, as we discussed in the halogenation reaction, that the bond will be reformed. So the bond is reformed again and this chlorine will be removed in the form of chloride ion. Here it is chloride ion. Now in the next step what will happen? This chloride will remove the alpha halogen at alpha hydrogen atom. This is the alpha carbon. So the hydrogen atom attached to the alpha carbon, it is alpha hydrogen atom. As we discussed earlier in Aldol reaction, that alpha hydrogen atom attached to the carbonylic carbon is acidic in nature. Here another functionality is also attached to the alpha hydrogen atom, which is nitrogen, and nitrogen has positive charge. So due to this reason it will attract electron or withdraw electron toward itself. And here is the carbonylic functionality, it also withdraw electron toward itself because both of these functionalities are electron withdrawing group. So due to this electron withdrawing effect, this alpha hydrogen will becomes acidic, or positive charge will be applied on this hydrogen atom, so it becomes acidic. Now what will happen? This chloride will abstract this alpha hydrogen atom, and the negative charge will be formed on this carbon atom, as you can see here. Negative charge is applied on this carbon atom. Now when this negative charge form bond with this nitrogen atom, the bond will be break toward nitrogen, and nitrogen will get negative charge. As you can see here, nitrogen becomes negatively charged and the central nitrogen atom becomes positively charged, so it resonates like this. In the next step, what will happen when this when this carbon with negative charge, when bond break toward nitrogen atom? Why the bond breaks towards nitrogen atom? Because nitrogen is positively charged and it is also electronegative than the carbon atom. So the driving force for this type of reaction is the removal of a stable atom, which is nitrogen molecule. So the nitrogen molecule will be removed from this carbon atom by breaking the bond between carbon and nitrogen. So what will be the uh, target product for this reaction, for this step? The target product for this step is the carbene, alpha ketocarbene. Here it is ketone functionality and this one is alpha carbon. So carbon at alpha position carbene is formed, so due to this reason it is alpha carbene intermediate. In the next step, this R group will be rearranged to this alpha carbon, and the lone pair of electron or carbene will form bond to this carbon atom or carbonylic carbon. As a result, ketene intermediate will be produced. This ketene intermediate is very reactive, and any type of nucleophile when attack on this ketene intermediate, so nucleophile will be attacked on this carbon on this carbon, which form double bond with oxygen atom and also a double bond with this carbon atom. So nucleophile will attack on this, as you can see here in this reaction. If we write here nucleophile, so different nucleophile we can use in this type of reaction, like water, like OH, like NH2 or RNH. So any type of nucleophile will can easily attack on this carbon of ketene. In this case, in the case of formation of carboxylic acid, water will attack on this carbon ketene carbon, and the bond will be break toward oxygen atom, as we discussed earlier that this bond will be break towards the hetero atom. So here the bond will be break towards hetero atom. So negative charge will be formed on positive, here negative charge on oxygen atom. So this negatively charged oxygen atom will gain one proton from this OH2, and it will be converted into this one. And in the next step, what will happen? It will be tautomerized into homologated carboxylic acid, which is the target product or the final product for such type of reaction. And here a rearrangement takes place. So what type of rearrangement is this? This is Wolff-rearrangement. So because of this Wolff-rearrangement, alpha ketocarbene will be converted into ketene intermediate. Let's have a look to some of the example here. It is first reacted with thionyl chloride. So with thionyl chloride, this OH will be converted into acid halide, and then by reacting with diazomethane, so a rearrangement will be takes place in the presence of this silver salt, in the presence of triethylamine as a base at this negative temperature, minus 20 degrees Celsius temperature. So this final product will be produced with 79% yield. In another example, it is first reacted with the lithium hydroxide. What will when this compound is reacted with lithium hydroxide, this ester functionality will be converted into carboxylic acid first. What will happen? This ester functionality will be converted into carboxylic acid first. Then this is reacted with thionyl chloride, and this thionyl chloride will convert this carboxylic acid into acid halide. And after reacting with diazomethane and the presence of silver salt, it will be converted into this homologated ester with 69% yield. If you like the video, please like and subscribe my channel, and also share the video with your friends. Thank you so much for watching the videos. Allah Aman.